So if you have so back to this. So if you have, let's say, something called sodium chloride. So what you do is you will write down the chemical symbol like this. Then remember you had the valency chart just now, or you can find the valency from the group number. Sodium comes from group 1, so it's 1. Chloride is also 1 because 1 minus. So with this, you can just exchange the numbers and then you get like that. This is the chemical formula. You crisscross and then you get the numbers. So because it's both 1, right, I'll just take away the 1. See? But now this one is sodium oxide. So sodium is 1 again and oxygen is 2. So then we crisscross and then you get the formula, which is this. Then once don't have to write, so we can just take it out like that. Then if you have magnesium carbonate, so this 2 comes from the periodic table. Then this 2 comes from your memory because just now I mentioned that there are a few that you need to memorize and this is one of them. Then when you crisscross, you get 2 here and 2 here, which is the same. So you can just write it out without the 2. That's why magnesium carbonate is like that. Then aluminum oxide, if you have something like a hydroxide, carbonate, you have nitrate, sulfate, all this, they all come in a group. They'll come in a group. So when you crisscross, you will find that this 3 will go to the whole hydroxide. Because of that, right, then you need to put a bracket like that. Then there's this. You crisscross, you get 2 and 4. Then you can just reduce it by a common factor, so it becomes 1 and 2. So down here is really, you have to go and remember that chart. Or you don't want to use the crisscross method, then you can use the way to understand the more diagrammic approach. So when bonding happens, we know that the positive charges and negative charges, they will balance each other out. So what happens if you have a compound that's formed between oxide ion and a sodium ion? The charges must balance. So in this case, right, there's only 1 positive charge and 2 down here. So you must have 2 sodium ions to balance this. So therefore, the formula comes out to look like that. When I write 2 down here, means there are 2 sodium ions. So so these 2 are balanced, so they straight away become like that. Then aluminum oxide, not aluminum hydroxide. So this is 3 and this is 1, so you need 3 of them, so become like that. So the bracket still holds. If let's say you write like that, then this is a totally different meaning. So in this, right, it means there is 1 aluminum, 3 oxygen, 3 hydrogen. If you write it without the bracket, this is 1 aluminum, 1 oxygen, 3 hydrogen. So it's totally different. Then in this case, the charges must balance. You have 4 here, 2 here, so you need 2 of this. So it becomes like that. Okay. Are you able to give me the names of the substance down here listed?
Magnesium chloride.
Second one?
Iron carbonate.
Third one?
Ammonium hydroxide.
Yes. Okay, now the more difficult one. Let's not do manganese. Okay, down to 3. Make a guess.
CuBr2.
Okay, this one? Answer was given.
Al(OH3).
Sulfur trioxide?
SO3.
Okay, good. Why it disappear?